Okay, guys. So before starting the webinar, just I wanted to show something on cloud computing. Okay, just what is the current situation in the cloud? Just I want to show the cloud trends. This is not related to webinar, but I wanted to give some glance on the cloud. Okay, so current cloud computing trends. First thing I would like to show you one thing. Cloud is basically the AWS, Azure are there since 2010, almost 10 to 12 years onwards. But real cloud computing, data migration, usage of cloud started from 2017-18, especially. So from 19 onwards, many companies started spending a lot of money on the clouds. Okay, so investments from the different companies. So if you observe from 2019, it's approximately $240 billion spent by different companies across the globe. If you observe that is in by 2022, that was $400 billion. It's approximately 23% increment year on year. Okay, which you can understand the cloud is growing very well. Okay, and another slide I wanted to elaborate more from since 2018 to 2020. It's approximately now 2022, expectation was 400, but really happened $490 billion, around 80 to $90 billion extra than previous comparison. Okay, and by 24, it will be $660 billion. Okay, just think, guys, nobody will spend money just like that. 100% they must have a clarity what exactly going on in the industry, how cloud will improve in the industry, right? So because of that reason, many companies started investing crores of money, I can say $1 billion of money across the IT industry through cloud computing. Right, guys? So these two slides, you can understand how much money invested already in the last 6 years and how much money is going to be invested, expected money in the next 2 years. Right? And another thing, if you observe, from 20 to 25, in the 6 years time, the job growth, approximately 149 million new jobs are creating by 2025. Ration might be there, but it's a little bit only. It will not affect entire software industry at all. Maybe just 5 to 10%. Again, within 6 months to 1 year, it will be back. Okay. So, but here 150 million jobs are creating by 2025 because of the COVID, lockdowns, digitalization, everything is becoming online. That is the reason most of the jobs are increased at this point of time, 23 to 25. Out of these 149 million jobs, if you observe, data-related jobs are more. Data. Now everything is data. 20 million jobs are data analysis, analytics, machine learning, artificial intelligence, and 23 million jobs are cloud computing, data engineering, data analysis, data migration. These kind of jobs are creating more. If you observe, data engineering is growing very well right now and even next 5 to 10 years minimum, for sure. Okay, so first two slides, how much money invested by companies on cloud computing, and these slides will give how many jobs are there, what is the job capacity in the digital industry, right? And next one is, which role is growing very well? Data engineering is growing 50% growth. Maybe number-wise less. In 2019, maybe only 1 lakh people are there. But in Java, 10 lakhs people are there. In Python, 15 lakhs people might be there. But growing wise, it's growing 50% growth since 2019. Still, okay, if you observe with other roles, cloud architect, DevOps engineer. DevOps was very good in 2018, 19, 20, but not really now. That time is for data. I'm not saying only data engineer, data roles. It can be data analyst, data analytics, machine learning people, data engineering, okay, business analyst. These roles are growing very well. Okay, guys. So these are the 3 slides. Simply, I wanted to show you to understand how many investments happen, how many newly jobs are creating, and especially data and digital area, and what is the role, importance of the data engineering. Okay, guys. And another slide, this is futuristic slide. In the next minimum 10 to 20 years, the entire industry will work with these three concepts. IoT, everything is becoming smart now. Okay, and artificial intelligence, machine learning, deep learning, data science. This is also going to, already it's growing. Okay, really it will be growing, will start from 25 as per my experience, my expectation. It will rule the entire software industry next to 10 to 20 years. Between IoT and AI, 100% big data is required. Without big data, these two cannot be executed. These two cannot be integrated, right? So big data is important. Big data on cloud is becoming cloud data engineering. Here in big data, what we will do? Capture the data. Whatever the data doesn't matter. Store the data, analyze the data, transform the data, enrich the data, provide the data to the business for reporting purpose, dashboard purpose, right? So these three concepts are very well. Okay, after this webinar, you may like it or no, I don't know, but try to be involved with these three concepts in IT industry. Your future will be good. Okay, just it's a suggestion as per my experience. Okay, guys, that's it. These are the 4 slides I wanted to show you before starting the webinar. So we have full of people, around 90+ people are there around. Okay, so I'm closing this PPT, which is trends. Now I wanted to start with webinar. Okay, before starting webinar, I wanted to explain about myself. My name is Satish. I have total 17 years of IT experience in the industry. My career started with pure Java developer, then Scala, Python. I worked with all 3 programming languages, but most of the time worked with Java. Okay, so in initial first year onwards, I don't want to stay in same technology more than 2 to 3 years. Okay, so I changed. Even in Java also, I started work with the core Java, servlets, then switch to JSP, Hibernate, okay, struts, EasyB. Like that, I have changed many Java technologies within the 8 years. Then started with Scala and switched to big data. This is the main switch happened in my career. Okay, after fed up with Java, after 8 years of writing thousands of lines of code, so I wanted to change something in my career. So then I elaborated the industry. I searched a lot in the Google. I found finally big data is the best one. Okay, I joined in. I did not join any course. Just I learned myself here. Okay, in 2013. Okay, with the help of IBM. When I was working in IBM, I switched it. So within 11 days, I got 4 of those guys. Within 11 days, with 170% hike. Okay, at that point of time, I decided I wanted to switch technology every 2 years. Then within the big data, initially I worked with Hadoop. After that, I worked with Hive, Spark, Impala, NiFi. There are a lot of technologies are in big data and NoSQL also. NoSQL is a separate concept. Okay, I worked with Cassandra and MongoDB, HBase. Slowly, I have to move because of the project into the cloud. The same big data is moved to cloud. Initially, I started working with GCP in 2018. And in 19, I have to work with Azure and AWS for 6 months and 1 year. Then again, moved to GCP. So overall, I worked with all 3 clouds in the last 5+ years. Okay, so this is the overall experience. Okay, guys. So now I wanted to explain a bit of data engineering. Okay, so data engineering, I wanted to make it very simplified words. Basically, data engineer will do 3 things, guys. 3 things, data engineering. One is collect the data. Second one is process or transform or enrichment the data. Sorry, second one should be store and then process. Okay. these are the three things will be performed by data engineer. Okay, so but many of you might be know about ETL. Okay, but I'm not talking about ETL. I'm talking about ELT. There is a lot of difference between ETL and ELT. So this is ELT. If it is ETL, collect the data, then process, then store. Okay, store raw data, transform the data, and finally serve the data to the business. Business or reporting or machine learning or dashboards. It can be anything. Okay, all these people are looking for data which is transformed, which is generated properly. Okay, so as a data employee, we have to collect the data, store the data, and process the data. These are the three things we want to do. Okay, so the same thing here I wanted to show you. Data engineering lifestyle will be first, data generation will happen automatically in the front end applications. I will explain little later. The data needs to be ingested. Ingested nothing but load the data, collect the data. Then after that, transform the data. Then serve the. This is again ETL concept. Load, transform, serve with the help of a storage. Then that data will be used by analytics, business, reporting. All these people will use it. So when you are working as a data engineer, you have to work with the underlying teams also, architects, data ops, okay, security, orchestration people, platform people. All these teams will be involved in the process of data engineering. Okay, here one more slide I wanted to show you. So data architects, DevOps, or SRE engineers will work on the platform side, how to make sure the platform is available. Then data engineer will start the real work of data collection, store, process, and serve to the business. So this is the business. So this is already existing one. This side is the people are looking for data, but here we are working as a data ingestion process. Okay. So here in this webinar, I wanted to explain or I wanted to discuss about these things. First, I would like to talk about big data concept quickly for 5 minutes. Then I will talk more about data engineering roles and responsibilities. Then I will explain ETL and ELT and OLTP and OLAP. Still here is completely concept oriented. Okay. After that, I wanted to show you how to build a data pipeline from taking one sales data to and giving data to the end user. Okay. So I did not give this kind of webinar till now. This is the first webinar. Okay. Still now I have given only demos. So now I wanted to show you a little bit technically. The people who doesn't have technical knowledge, excuse me, just you can try to understand. Okay. So by end of this session, you will understand how to build a data pipeline and what is the data engineering work. You will understand. Okay. So let me open a slide of big data. I will not take much time here. Okay. So basically, what is big data? Many people think big data is a database. Big data will store the data like that, right? But the thing is, big data is not a technology. Basically, big data is not a tool. Big data is not a programming language. Big data is not a database. Big data is not a data warehouse tool. It's a concept. That's it. Big data is just simple concept. If you take any concept in the world, that concept will depend on rules and regulations. That concept will elaborate the things, how to do, what to do. That's it. But some other tools will follow this concept. Okay. So I wanted to say big data is a concept which can elaborate, which can define the characteristics of 3 V's. Volume of the data, velocity of the data, and variety of the data. Before big data, IT industry was struggling to store the huge amount of data. because of the mobile applications, internet, web application. People started using everything through internet. Huge data is generated. So industry is not able to store that huge amount of data in proper way. That was the biggest problem in the industry. After that, how to process that data? That is again a problem. Okay. So if it's a 1 GB data, 8 GB RAM can process. If the data is increased to 100 GB, how can you increase the RAM from 8 GB to 800 GB? Not possible, right? So that was the again bottleneck here. And third thing is, data initially is coming as structured data, like a record, like an employee number, employee ID, salary, like that. But after that, we have started using social media. Okay, we are sharing the photos, pictures, videos, audios, everything we are started sharing. Then unstructured data, semi-structured data started. The industry, the technology is not sufficient to manage this. So at that point of time, big data came into the picture. Okay, it's defined how can we solve these problems. Okay, and the latter point of time, IBM added one more we call veracity. Volume, variety, velocity, and veracity. Veracity nothing but data is coming but not clear. Data. So that kind of data can be considered as a veracity. Okay, these are the different slides I wanted to show you how data is considered. You can see the volume is nothing but data in rest. Velocity is nothing but data in motion. Variety is nothing but data in many forms. One is table, one is text, one is picture, one is video, many forms. Veracity is nothing but data is coming but not clear, some of the data. Okay, these are the things. Okay, so volume can be calculated like this. Velocity can be calculated like a speed of the system. This is different forms, different colors of the data. Veracity, that the record is there but not clear what is that. This is the different kinds of slides I have given to understand more. Then volume. So maybe people think about why too much volume is coming. Is it really required, really happening, right? If you observe in 2005, the total data was 130 exabytes of data is there in the worldwide. In 5 years, it is increased to 10 times. In 2 years, it increased to 20 times, or it's double. From 12 to 30, 15, 3 years, you can see how much time data. Okay, so data can be calculated like this, right? Exabyte is this one. After terabyte, petabyte, exabyte will come to the picture. Okay, so really 2015 also not a big deal, guys. The real data happened from 2020, especially after COVID. Okay, huge amount of data started. So some of the examples, one airline collected 10 terabyte of sensor data over 30 minutes. Just think how many airlines are there in the world, how much terabyte of data is generated. Okay, New York Stock Exchange is generating 4 to 5 terabyte of data every day. Trade data. How many stock exchanges are there worldwide? Okay, just example, Facebook is dealing with 900 terabytes of data per day. Yahoo 190 petabytes of data, eBay 15 petabytes of data. Right? And you can see 1 minute what is happening in the world. In 1 minute, the people are uploading 300 hours of videos in 1 minute. Okay, then how Google has to maintain this data? But when you click something in YouTube, you will get the answer within seconds. How they are managing? Okay, Twitter, see, Skype is having 1.1 lakh calls in a minute. Understand, guys? This has happened. This is a slide, 2019 slide. This is the recent slide. Now you can see. Okay. In 1 minute, 700,000 of hours of video watched by people. Okay. See, like this. Twitter, 575K. The 5 points are approximately 6 lakhs tweets are shared in a minute. So I don't want to read everything here. Just you can understand how much data is loading, how much data is generating tweets. Okay, but that previously before big data, the systems are able to manage GBs of data and 1 to 2 terabytes of data. This line is 2013, I can say. Before 2012-13, the data was approximately GBs and just to touch TBs. So database RDBMS systems, Oracle, DB2, and some of the Teradata, Netezza, Informatica, these kind of tools are able to manage it. But data is crossing terabytes to petabytes. No, all are crashing. Then what is required? We need distributed solutions required. And big data has to be started for sure. Okay. So you can see another examples, Google data. Even our other data itself is a 160 petabytes of data we have right now. Okay. These are the volume. Variety is simple thing, yes. Everybody knows about it. Structured data, which is considered as a table and a CSV file. Okay, guys, I'm going a little bit fast now because of the webinar. Okay, so if you are not able to follow some of things, you can join next demo or webinar. Okay. So this is structured data, semi-structured, nothing but XML data, JSON data. Maybe some of you might be know about this, right? Data will be coming in the form of CSV, okay, tab separated value, okay, XML value, JSON value. These are the different data formats we have. On top of this, we have Avro format, Parquet format, ORC format. There are different formats. You need not worry, but as a data engineer, you have to deal with all these formats. Okay, so XML and JSON format comes under semi-structured. Unstructured is nothing but anything. Video, audio, picture, all comes under unstructured. Okay, and next, velocity. Velocity is nothing but data is already there in the hard disk. We need to process it, right? That is called velocity. Okay, if you click on a movie, sometimes if the RAM is low, the movie will not show immediately, right? It will take some time. So that means data is processing internally. If you increase the RAM, then data processing will be more. So that is called data velocity. Clear, guys? So this is the about big data concept. Just I wanted to go through. So because of this big data, people need some technology. The existing technology is not sufficient. Then what to do? When existing technology is not sufficient, we have to go through the advanced technologies, right? So to solve all these problems, we had a tool called Hadoop. Hadoop was the first tool which can deal with all three ways. There was no other tool. Maybe some tools may be good with processing. IBM tools good with storing the data. Okay, but the Hadoop was the first tool developed by some companies like Yahoo and other companies. They have implemented all three in single tool. Okay, then what is Hadoop, guys? Anybody? What is Hadoop? Hadoop is a concept? No. Big data is the concept. Hadoop is a framework. Hadoop is a framework. Again, it's not a tool. Within the Hadoop, there are multiple tools are there. Okay, multiple tools are there. The framework is nothing but something can have a predefined libraries. Okay, predefined libraries, some set of things will be defined already. Things are there. By using this set of things, we can implement our application. Like in Hadoop contains HDFS, MapReduce, Scoop, Hive, like this. Okay. So still as a data engineer, we have to follow these things. These are the basics of data engineering, right? So here, what is the advantage of HDFS? HDFS can store the data. As I told you, right? Collect the data, store the data, process the data. So HDFS can store the data. Scoop can collect the data. For collecting, there are multiple tools are there, not only Scoop. Scoop can collect the data only from database. Many people think Scoop is something. Scoop is nothing but, guys, SQL, Hadoop, that's it. SQL Hadoop, okay, first 2 characters of SQL, last 3 characters of Hadoop is become a scoop. That means the scoop tool can collect the data from SQL systems to Hadoop, collecting the data. MapReduce is the tool for process the data or transform the data. The Hive is for, it's a data lake concept or data warehouse concept, which Hive can serve the data to the end user. Even within the Hive also can do some transformation with the help of MapReduce. Yeah, as a big data engineer, we have to use these things. But now Hadoop is already in the dead state. It's moved out of the scope. But now we are using cloud tools. I will tell you what are the cloud tools we are using for this. Okay. But before going to the cloud data engineering, we have to know this. In my courses, I'm taking at least 3 days of classes on these 3 things. Yeah, yes, Vishwa, it's a big data tool. Okay.
Hello,
so
Satish,
yes.
can I have a question, please?
Yeah.
Okay, thanks. Satish, actually, you have mentioned in that same pane, the second row you mentioned store raw data, right?
Yes.
So, okay,
Store
what
raw.
is this? Okay, in that case, so you'll be connecting the data from the source, correct?
Yes.
Okay, the store raw data in the sense it is a data stage layer or what it is?
It's a raw layer, not like, cannot say stage layer, it's a raw layer. Okay, from raw layer to X-ray layer, we will transform the data with the help of these tools.
No. Store raw data in the sense you'll be storing the raw data in the data stage layer, or how it will be?
It's not a data stage, it's a storage layer, simple storage, that's it. Data stage is something different. It's a storage, okay. You can store any data here. You can not only structured data, semi-structured data, unstructured data also. Okay. I will clarify that very soon. When I'm going to explain data engineering roles and responsibility, I'm going to clarify. Okay. Yeah. Guys, any question? I will take the half an hour time. I will give. You can ask any question. Okay. Let me complete them. Okay. So this is about big data. In big data, these are the tools are there. Hadoop is a framework. In Hadoop, we have multiple tools are there, which you can complete the data engineering end-to-end on-prem. This is on-prem. Okay. Now we can go to the cloud. Before going to the cloud, I wanted to show data engineering roles and responsibilities. Okay. For data engineering roles and responsibilities, basically, as I told you, data engineer will collect the data. Okay. From where he will collect? Okay. He will collect the data from source systems. He will collect the data from source system. This is the one line I wanted to divide. This is the other line. Okay. So the data engineering responsibility is nothing but sources. This is target or business. Okay. Here, what are the sources are available in the market? Databases mostly. These databases will store the data from the front-end applications. Front-end application will store. And we have other file systems also, Walrus and file systems. We have IoT sensors also started coming. And we have maybe other on-prem called HDFS. Hadoop is also maybe the source system. Okay, or else we have maybe other source systems also there. Okay, so as a data engineer, we need to collect the data into the system. This is called collect the data. So the collecting the data may not be same from each source, right? Again, I wanted to talk 2 things here. The data can be available in 2 ways. One is batch and the streaming data. This streaming data can be called as a real-time data or near real-time data. Okay, if the data is batch, the collecting process is different. If the data is real time, the collecting process is different. Okay, so here the tool which you are using here is different from technology to technology. If you are using big data, this will be scoop. If you are using Google Cloud, this will be different. If you are using Azure Cloud, this will be different. Okay. And a folder, again, different way. If it is a continuous process, continuous data is coming, suppose, then NRT data, we will use tool called Kafka. Okay, Kafka, there is a tool which you can collect the data continuously. The tool, we can use Kafka here. Here you can use Scoop like that. Okay, so based on the source system, the data loading will be different. Okay, after that, here we have environment. I would like to say this can be a cloud or this can be on-prem. So now I wanted to talk more about cloud. So this is cloud environment. In the cloud, it can be GCP or Azure, any cloud. So once you collect the data, we cannot collect the data directly into cloud from source systems. For that, in many companies, in the real time, we have a area called staging area. Or I would like to call it as a not staging, it's a landing zone. I would like to call it as a landing zone. Okay, so first the data will be landed to this place. Then the data will be collected and stored into the real data storage called, this is called storage. Here collect the data, here store the raw data. Say raw data. Okay, this landing zone is temporary zone. We'll take the data from here to here. This is the fixed storage. Okay, so here, what is the tool? If it is GCP, we will use GCS, Google Cloud Storage. Okay, if it is Azure, we will use Blob. If it is AWS, we will use S3. Okay, we will use S3. If it is clouds, all three clouds, we will keep the data here. So then we have a data warehouse system will be available. We have a data warehouse system. In this data warehouse system, we will take the data and process the data here. Here we will have a different layers case. We have a different layers. Generally, in most of the companies, 2 to 3 layers are there. 2 to 3 layers here basically. So here we may use transformation mechanism before loading from store to here. Here can use transformation mechanism. For this transformation, we can use basically Spark. Okay, Spark is generic word. In AWS, the name is different. Okay, in GCP, the name is different. Okay, we can use different names, but Spark, now we are focusing mainly PySpark, Python with Spark. We can use and transform the data into this place. Okay, and then this is called stage layer. Names may be different. Few companies will use stage, and then this is called a history layer, and this is called views layer. Views. Okay, as I worked within 5 years in the cloud area, in different companies use different names like silver, gold, platinum. Okay, few companies will use raw data, refined data, okay, visualization data. So name can be anything, guys. It's up to company may change, but there are 3 layers. Okay, which this one? Raw data, refined data, history. Yeah, history. Okay. I'm coming. Say history. So
visualization.
View means not visualization. It's a view only. In the RDBMS view only. So the stage data is a temporary data. From here to here, we will do another transformations. Our database level transformation we will do. Changing the date format, concatenation, LPAD, RPAD, okay, removing the spaces, modifying the data in a proper way, implementing the security systems like encryption, decryption, masking, unmasking, everything can be applied here. Then stage data will be full load. Total data is there. If the client wants 5 years data, entire 5 years data will be available. Okay, from here to here, what will happen? We will create the multiple views on the history based on the requirement. Suppose here reporting people are there. Reporting people wants to retrieve the sales data. They need only sale amount, profit, loss, and price amount. That's it. So why should we give entire data to this reporting people? There are 100 columns are there in the table. Not required, right? We will control that in the views. We will create multiple views. One view for reporting people, one view for machine learning people, one view for dashboard people. Okay. One view for messaging system people, like that. Okay. Yeah, data will be moved from stage, deleted. Okay. Here, target systems. Initially, only reporting people was there, right? Till 2018, 17, 18. After that, especially machine learning, data science people started using more data. This is the main reason data in the roles are increasing. Okay, and then dashboards. Okay, and then messaging systems. Messaging systems. Other third-party systems. Other clouds. All these people are looking for data. See, the target set people are increasing. Initially, only reporting, data warehouse tool was good, Hadoop was good at that point of time. But now, not like that. It's got increased too much. So here also the requirement got changed. Understand? So as a data engineer, we have to involve in this area. We have to involve from source, touching from source to giving data to this. From here to here. This is the main role of data engineer. Whether it can be a Google Cloud, Azure Cloud, Hadoop, doesn't matter. They have to touch the source system to collect the data. They have to talk to the business people, what kind of requirement they want, what kind of data they need. Understand? Now you can understand the importance of the data. Without this process, any company exists? Any company exists in the process? No, right? 100% it is right. Many of you know the people who are experienced.
Satish?
Yeah, can I take the questions last if you don't mind?
Thanks. Yeah, Satish, this is fine. Here in the target, will be having a database or how it will be?
This one?
Target or business? Target.
Target can be anything. It's a machine learning data science. That can be database, data analytics, something. They can use anything. Python, they can use C++. They can use other language. Doesn't matter. But
No,
here,
the database. I mean, here you mentioned history is a database layer which contains everything, right?
Database.
Correct. So history is similar to the target system. It should be present in the target also, correct? I mean the data warehouse.
This is the data warehouse system.
Oh, okay.
From data warehouse, they will track the data. Okay. For these people, source is view, which is available in the data warehouse.
Okay. I mean, history and view will be same, and you will be fetching the report. I mean, fetching the data for the reports and also for the messaging parties.
Exactly. This is called data warehouse.
Okay.
So I would like to give the names also. What are the data warehouses familiar right now? Everybody knows about Snowflake. Okay. Snowflake is not belongs to any cloud. It's separate. But in market, AWS, there is a data warehouse called Redshift. Okay. In GCP, BigQuery, which is very good case, this BigQuery. BigQuery is already crossed Redshift and Synapse. This is completed to Snowflake. Okay. I can talk 1.5 hours continuously on BigQuery. Okay. Too many things are implemented by Google. And Synapse. From Azure. I have given all 4 top data warehouse tools in the market right now. All are cloud data warehouses. Before you may heard about Informatica, Netezza, Abinitio. Okay, time I went. Okay, it's completely cloud. So now here we are using these things. If I'm using GCP, BigQuery is the data warehouse tool. Synapse is for Azure. Some of the people, Azure people are using Snowflake. Redshift is AWS. Understand? Here, as I told you, GCS, Blob, S3. And here, Redshift, BigQuery, Synapse. Okay. So these are the tools we need. Okay. So as a data engineering role, so I told you these are things, but what technologies needs to be learned? That is important, right? Okay.
Sir,
So
Satish, where integration tools will sit in this picture, like Dell Boomi, something integration tools?
Here. Okay, I did not elaborate much. There are multiple Dataproc, Dataflow, okay, Athena. There are many multiple tools are there here. So from multiple clouds, I did not give all this. Dataproc is nothing but a Hadoop on cloud. Hadoop on Google Cloud. Okay, yeah. So there are multiple tools, guys. Dataproc is from.
Satish, sorry for disturbing.
Yeah.
So Dataflow, Dataproc, right? So
Yeah.
in the Dataflow, it comes as a ETL tool, or Dataproc is a ETL?
Dataflow is ETL tool. Dataproc, we can use it as a processing tool for PySpark.
So there is no more data flow.
Dataflow, that's what. Dataflow is a completely ETL tool. And we have Cloud Composer. Composer is nothing but Airflow.
Yes.
Okay. As a GCP engineer, you have to learn this.
Data flow is from
One. Dataflow is developed by Apache Pig. Apache Pig. Dataproc is nothing but a Hadoop. Okay. So these are the Google Cloud tools developed based out of these tools.
you should learn this now.
Yeah. So as a data engineer, we have to learn SQL first, because of we have to work with data warehouse called BigQuery. We have to learn Python scripting, which you can use this for multiple reasons. Python scripting only. Only Python scripting is more than enough to write.
Sir, I have one doubt, sir.
Yeah, I can take all questions, sir.
One question,
Please.
sir. Which
Please.
Oracle, which SQL is best, sir? Google for Google, Oracle, or SQL Server?
Anything is same, guys. Okay, any SQL is same, no difference. Okay. Yeah, please, let me continue. Python scripting for Airflow, Dataproc, Dataflow. Okay, so to work with all these tools, we need Python. And in Azure, we will work with Databricks, PySpark, which is very, very popular. Okay, SQL is one, not only BigQuery, for Snowflake also SQL is required. Okay, so SQL and Python, to work with these advanced technologies, you need to learn. Okay, right now in the market to get the job quickly with high package, these technologies are more than enough. That's it. Whoever good with SQL, Python scripting, either BigQuery or Snowflake, one is enough. BigQuery and Airflow, Dataproc, PySpark. That's it. Okay. In the last 1.5 years, I have seen multiple people who are good with these technologies. They got 100% high practice. 100% high. Okay. So second part is done. As a data engineer, roles. Collect the data, store the data, and responsibilities. What are the technologies also required? I have explained. So now just I want to talk something about ETL and EL. Okay, basically the ETL nothing but first to extract the data, then transform the data, then load the data. Right? And ELT, extract is common. After that, we are loading the data, then transforming the data. Okay. By looking at here, it's not showing big difference, right? Just exchange rate. Okay, but current industry, it's giving a lot of difference. Okay. Suppose simple example. There are multiple examples I have, but I will give one example. Suppose source system is here in US. Okay. Source system. Now I'm collecting the data. The transformation, I'm going to talk with ETL. This is a transformation. I wanted to take the sales data, transform it. It is in maybe as transformation ETL tool in India. Then the warehouse system, after transforming loading the warehouse system is maybe in US, UK. Okay. The data every day is coming, approximately 10 GB data is coming. 10 GB data needs to be transformed across the network, one country, another country, and processing the data, then give it to these people. Okay, suppose due to some reason, after 95%, due to some reason, it's got failed job. Then you have to start from zero, right? That is the problem. But these people are waiting for data, but data is not available. Slowly, data is increased to 10 GB to 100 GB. Initially, it was taking 1 hour time to process the data. Now, it is taking 10 hours. Who will wait for 10 hours to process the data? Understand? I'm talking about the world ETL transformation system. Okay, good. It's transferred very well. One business people wants to take the data, transform data in one way. They have taken data. Another guy wants to take the same data in a different transformation. Again, you have to load the data, right? 100 GB. Okay. Again, you need to transform in different way, multiple times. If it is failed, taking too much time, lot of efforts are wasted, and this is cost too much cost. These systems are. Okay, costing is high, lot of differences are there. But where it is a ELT, when we started cloud and Hadoop, the ELT system, the database is here. We are collecting the data only once. Collect. Then whatever the data stored in the raw, this is raw area. Then within the same environment, we can process multiple times. Wherever the data is there, go and process it. That's it, which is easy, right? So from X person wants to some transformation, they can do. Y person wants to do some Y transformation, they can do. Data is collected and loaded only one time. Understand? Here, and one more thing you can ask, after 90% may fail, right? So now current distributed systems are following, especially big data and cloud systems are following few concepts like distributed architecture, scalability architecture, partitioning concept, okay, and fault tolerance, high available, and moving computation. These are the things following by all big data and cloud technologies. So whatever the data 100 GB you are copying, that data is not storing in single machine. That data will be storing in a multiple systems. Okay, all systems are connected internally as a network or cluster. Cluster. Initially, only one machine was there, one hard disk, one RAM. If data is huge, the time is taking more. Even if you want to increase the RAM, maybe you increase to 16 GB, 32 GB, not more than that, right? So there is a problem. That is the reason people switch to distributed architecture. 4 machines are there. Whatever the data I have, that will be split into 4 parts as part of the partitioning technique. Data will be stored in 4 places. And the data will be processed in all 4 systems parallelly. Understand? That is the reason data can process quickly. Suppose these 4 systems are not sufficient, then scalability feature. Scalability nothing but increase the resources. Whenever you want, you can increase the systems. That is the scalability architecture. Okay, all big data tools are scalable, partitioned, distributed.
Satish, what is the performance of between ETL and ELT?
Yeah, that's what. Performance is 100% increase, right? Multiple machines are working here. Data load once, read many times. Data need not to be load again and again. Okay. I would like to show one thing. Even you can go through this, guys. ETL and EL. I will show this table and I will conclude it. This one. Extract, transform, load, extract, load and transform. It's completely cloud-based. Okay. Technology-wise, relatively matured and relatively new, but it's also matured right now. Okay. So it makes more difficult to work with large volume of data. This is the reason ELT is increasing. If data is 1 GB, 2 GB, 10 GB, doesn't matter. CTL is fine. But when data is increased, it makes easier to work with large volume of data. Okay. See, expensive, cost efficient in cloud, but on-prem expensive, but here completely cost efficient, less cost. Maintenance is little bit maintenance, but here a lot of maintenance are there. Everything you need to take care. Data loading is slower, data loading is faster. So I can give this maybe in the chart window. You can go through for your knowledge. Okay. So Informatica, Cognos, these type of tools are there, but we have multiple tools are there in the cloud. Okay, small portion of data, it is better. Okay, structured data, but here any kind of data and how much use of data is doesn't matter. Any size of data, this will be good. Okay, guys. So nowadays people are using ELT, not ETL. That is for sure. Even you can say we are doing ELT. But many companies call it as if we are doing ETL. No, they are doing ELT. If they are using cloud, that means they are using ELT. Okay, guys. So ELT is more better than ETL. So distribution architecture, scalability. Actually, in my classes, I will take 2 hours to explain these 5 things, but I'm giving just overview of these things. Okay, and the fault tolerance. Fault tolerance is nothing but if suppose due to some reason system got down, then one portion of data is missing, right? So there is a concept called replication. Each and every copy of data will be 3 copies. Even 1 copy is missed, the same data is not be available somewhere here or here. Data process will not be stopped. Understand? Due to some reason, even network is down, doesn't matter. Other systems are there to take care of the process. Understand? So with the help of replication, fault tolerance might be happening. Fault tolerance is if any fault happens, still we will be able to tolerate it. We will be able to recover the data. Okay? High availability, again, 1 system down, 2 systems down. We have multiple systems to handle the process. High availability, no downtime. 24/7, 365 days, system will be available for running the data, processing data. That is called high availability. So, and the moving combination means data copied once, that's all. Next time onwards, computation will come and process. Java program will come here and process. SQL will come and process. Python program will come and process. That is called moving computation. Previously, moving data, one place to another place. Okay. These are the best features, guys. All these features are available in Hadoop. Okay, let me change the color. Hadoop, Spark, NiFi, all cloud tools are having these features. Understand? So as a data engineer, we should be having 100% clarification on these 5 things, 5, 6. Okay. Next, OLTP and OLAP. Anybody have any idea? OLTP, OLAP is nothing but online transaction processing, online analytical processing. Okay. In the industry, the software systems are in 2 ways. One side is OLTP, other side OLAP. OLTP is nothing but whatever the transaction you are doing in the daily, day-to-day basis, that is called OLTP. Okay, suppose you are using mobile phone every day to do many transactions, booking the tickets, movie tickets, flight tickets, okay, paying money through PhonePe, everything is happening. Or else maybe you are using desktop web applications. All will be processed in the middleware. This is called front end, right? But that data will be stored database called backend. This is called backend. So many people are learning Python, right? Full stack developer, front end developer, backend. Those people will work here. Okay. Even in my first 8.5 years, I worked with the middleware technologies, implementing these things. So this is called OLTP. So for any company, OLTP is the main money generator. You can say money generator for any application. In Zomato, you are booking a biryani. That means the money generator for Zomato and a restaurant, like that. So this is called OLTP. But OLTP is nothing but, as I told you, collect the data, store, process, and store into data warehouse. Already I have explained, right? So in this place, you can say this is the process. Now this picture I can replace here and I give it to the business. This is called OLAP. As a data engineer, we are going to work with OLAP process. Okay, the online analytical process. Okay, here what is the advantage to take business decisions? OLAP is required, right? Okay, because of how much profit in 2022. How can you know? Collect 1 year data, process, analyze it. Okay, which product gives more profit? Right? In Tata, there are multiple vendors, multiple segments are there. So you wanted to know which car is giving, which model of car is giving more profit. It has to verify, right? Right? So how can I have to take the data, I can analyze like that. So I wanted to compare with the last quarter with this quarter. I wanted to analyze it, maybe summer is coming. So in my company, there are multiple products. Which product will be good in the summer? How can I know? I have to go to last year summer. Before last year to summer. I have to search last 3-4 years of data from March to June, which product is good. Then I can have an idea. I can do this year. Then I can increase the business, right? Understand? To run the business, this is required. To take the decision, OLAP is required. Okay, the front end is OLAP, which is important, right, you guys, for a business? Both are important. Okay, it's automatically it's happening. So to increase or decrease, how decisions will happen? Here, if this is not there, we don't know what is happening. Business is running, we don't know whether it's profit or loss. We cannot increase our business. Understand? So nowadays, all companies are focusing on OLAP. This is happening last 20 years. Many businesses, but OLAP started last 5-6 years to increase the business, to take the decision. Understand? So this is called OLAP and OLTP. I can give slide for this also. See, the purpose is collect, store transactional data. Okay. Here, aggregate the transaction. Aggregate means collect the entire data, 1 day data, 1 week data, 1 month data, like that. Okay. Here, mostly people will write insert, update, delete queries. Quick updates, quick delete, but here not like that. Here, complex queries will be there. Joins, grouping, sub queries will be there. Okay. It's completely a transaction, but it's an aggregated transaction data. Okay. This can be done fast changes, fast updates, but it's not. It's large amounts of data. Batch wise, it will update. Okay. Data view will be one-to-one direction. Yeah, it's a multiple direction, multi-dimensional. Okay. Here, the transaction time is short transactions, seconds, milliseconds. If you are transferring money or using PhonePe, within few seconds you will do, right? But here, to take the decision, last month is good or bad in terms of sales, in terms of profit, in terms of orders. So the query will take minutes or hours. No more hours, guys. So when we move to cloud, everything will be seconds and minutes. Okay. Previously it was hours, but now only minutes. Understand? See, data analysis, machine learning, business people, all these people will require this data, this process. Front-end applications of business will require this particular OLAP. Okay. Okay. So as a data person, data engineer, we have to know about OLTP, OLAP, ETL and ELT. Okay. I have just given brief, guys. Okay. So I hope you understood. Here, next, cloud storage. First of all, before going to the cloud storage, if I want to start a data engineering process on cloud, we have to first get the cloud account. Okay, get the register the cloud account. So right now, GCP Google Cloud is giving 90 days free trial. Okay, Azure is giving 30 days free trial. 30 days free trial. So for learning purpose, we need not spend any money. Just you can register with the Gmail ID. Okay, and register. I also registered with my people here. Google Cloud is very simple. You can click on enter console.cloud.google.com. This is the website address. When you register, it will be registered with your Gmail ID. Okay, and you can see how much money is available in your account. If you go to billing, see guys, here you can see $300 means 24,000 plus. This person already used approximately 1,000 from 24,000 this much. Okay, that total days 90 days. I think it's approximately 10-15 days over. So you can utilize these credits for any component. Okay, so even without registration also you can see, guys, you can go and you can see all these things. All the components are available here, left side, navigational menu. Okay, here you can observe all components. There are 100 plus components are there. 100 plus components. If you are a database administrator, you need to learn these things, database. Okay, if you are a let me put it in the another way. View all products. If I click, I can see here. Okay, see management side, computation side, storage. So we have to know about storage first. In Google Cloud, there are multiple storages are available. This is called GCS, which is object-based storage. Object-based means it can take any kind of data, whether picture, video, audio, text, doesn't matter. Okay, file store is only for files purpose, like that. So as a data engineer, we need to learn this part. Okay, data storage. This is under storage. And next, analytics. Analytics is the main part for us, guys. See, okay. If you go to analytics here, yeah, as I told you, right, BigQuery is the heart of the program, data engineer. And PubSub. PubSub is a tool like a Kafka. I told you, right? Kafka is for real-time data. So we will use PubSub, publishing subscribing mechanism from Google. Tool name is different, but usage is same. Yeah, we'll create everything. Next, data flow. I told you, right? Streaming analytics service. Data flow advantage, it can work with both real-time and batch data also. See, real-time batch and streaming data can be processed in the pipelines. This is the good thing. Very well. It's growing very well. And Composer is nothing but Airflow. Composer is nothing but Airflow. You can observe here. Built on Apache Airflow.
Okay, so they are using Apache
Airflow with fully managed. Okay. The data proc is nothing but see Apache Hadoop. Apache Hadoop on Google Cloud is data proc, which can be managed Apache Spark and Hadoop services. Understand? And next, till here is good for data engineer. After that, if you observe, this is data prep is for data machine learning engines. Machine learning, see here. Okay, data prep is for machine learning purpose. And IoT core is for IoT people. Okay, but these are deal with data. Okay, data fusion is also a pipeline, zero coding pipeline, guys. This is also growing very well. Build, manage data pipeline, okay, without any coding, zero coding. You need not write one line of code, you can build entire pipeline. Data fusion, okay. And Looker is again growing wonderful in the market. It's like a reporting tool from Google, like Power BI, okay, like ClickSense, ClickView, like that. But here the Looker is enterprise BI analytics tool on top of machine learning and artificial intelligence development. Okay, embedded analytics. Okay, guys. Only on Looker, if you observe in Google, there are 20,000 plus jobs are there. Looker jobs in Naukri. 27,000 jobs are there. But nobody teaching in India. Okay, we are planning slowly. Okay, Power BI approximately less than this. Okay, so Looker is very good in the market. If anybody have a chance, you can try. Okay, and that's it. Remaining things are predefined product. For healthcare, they can directly use it. Financial service, they can directly use it like this. There are many. And a Databricks, third-party tool with PySpark. Okay, like there are many things are there. And networking. The people who are working in networking side, they can learn these things. The people who are working on server application development, they can learn these things. Database side, this one. Okay, operations, monitoring, security, CI/CD pipeline, DevOps people will work here.
All this we can learn.
Yeah. Okay, cloud is nothing but not only for one segment. Cloud is a platform. It can serve for all segments. Yeah. Artificial intelligence people. These are the tools. They have to learn vectors. They have to learn natural language, NLP. These things they have to learn. And then integration tools. Okay, and the other tools, development tools. Okay, supporting tools. All tools are available. Gaming, mobile applications, everything is available in Google Cloud. But as a data engineer, we will focus only on data engineering related part. Okay, now once the registration completed, I can simply create a bucket here. Click here. There is a component called cloud storage. Okay, click cloud storage. Then it will open the window. Simply you can click create a bucket. Okay, here in Google Cloud, they are providing storage area across the globe. Okay, so here you cannot give something else. See, guys, pick a globally unique name. Because of if I'm using my account here, somebody using different account, but both will be considered as a same storage. So the storage name should be completely different. I would like to give it as a Cloud Data Engineer CDE. Okay, some webinar. Okay, so it's fine. It's unique. Then I'm not going to explain everything here. I would like to show here we can choose the where do you want to store your data, in which region, US region or Europe region, Asia Pacific region. Okay, and a dual region or else single region. Okay, the advantage of multi-region is it will copy 3 places. One region is getting down, 2 other regions will provide the data. Single region is nothing but only one region is there, but data latency will be good. You can pick the data very fast. That is the advantage. Okay, so Google implemented infrastructure very well, guys, right now. GCP, regions and zones, if you see, there are let me open. There are 30 plus regions are there across the globe. 35 regions, 106 zones, 176 network edges, 200 plus countries are using Google Cloud. Okay, 5 years back, Google Cloud was nothing. Okay, it was in 7th or 8th place. Now it's in 3rd place After AWS and also this is the group. Okay. The network regions. So not only Google Cloud, in Azure also having almost 30 plus regions are available across the globe. All three clouds are doing very well right now. So you can, but as per this webinar, I wanted to go with Google Cloud, which is available with me right now. Azure is not available. That's the reason I'm going to show you GCP. So here I'm creating a bucket in GCS, right? If it is Azure, I will create a blob. That's it. Okay. So I can select a multi-region. I can choose storage classes like standard, nearline, cold line, archive. Standard is for retrieving the data frequently. Cold, nearline for monthly. If you are retrieving. Suppose you are retrieving quarterly, go for cold line. You are retrieving data yearly once or maybe more than that, you can go for the archive. So there are many things are there. So I'm creating a standard bucket with the multi-region. The cost also will be given here. $0.026 per GB per month. Very less cost. GCP is cost effective. Very less cost. So creating bucket is very simple. I can create bucket like this. Confirm. Okay. But in real time, nobody will create bucket like this. Okay. So as a developer, if you create a bucket like CDE webinar, how this bucket will be created in production? Will you get access like this? No, right? Nobody will give access like this. So everything should be done through command line. For that, each developer has to install SDK software or Cloud Shell software. SDK means software development kit. If you are working with the GCP SDK, you have to install. If you are working with Azure SDK, you have to install. Or else active shells are there, cloud shells you can use. Okay. Now I wanted to show you how to create a bucket through command line. Okay. So for this, I can SDK, which is available, Google Cloud SDK. I can click this. Now I have to connect with Google Cloud from here and I can do. But now I wanted to show you in a different way in Cloud Shell, active Cloud Shell. This is also same command prompt. When I click here, it will open a separate Cloud Shell here. I would like to open a separate page for better view. Okay. Okay, this is the shell I'm using right here. I wanted to work with Google Cloud. I need to go with G Cloud. Okay, and I can give anything, BigQuery, instances, computers like that. And at the same time, if I want to connect with storage area, here I'm going to the cloud storage. I'm going with the buckets. How many buckets are there? There are 3 buckets are there. One is CD web I have created just now, sales CD and some other bucket is already available. If I wanted to see these buckets from source end, I need to write the command lines. GS util ls. It is asking for the. See guys, these are the buckets I have created. So in real time, as a data engineer, we have to use this manner.
To go to this shell, I have to log into the
Console.
go and create the bucket there.
Yeah, in that is the reason we can go with the SDK. SDK will be installed in your local machine. You can, without connecting to Google Cloud, you can do from here. Okay. So if I want to create a bucket, GS util MB make bucket. Okay. Here we need to learn one more thing, guys, as a data engineer, technology wise. You have to learn. Just a minute. I have given the technology stack, right? Okay. Yeah, we have to learn Unix commands along with SQL, along with the Python scripting. This Unix commands also required, Unix or Linux, because we are going to deal with this kind of architecture. If you know Unix, you know what is LS list, right? If you are using Unix, you know mkdir, make directory. Here we are using MB, make bucket. GS Google Storage, // like HTTPS, HTTP protocol kind of. Huh? Sorry, MB. Make bucket. CDE hyphen where. Just I'm trying to create it. Now you can see it's already available, right? See guys, CD web is already exist. Try another name. Because of it's already there. Just I created. I'm using same name again.
Now, how it will ask me which region I have to take.
Yeah, I can give.
Okay, here we are.
Yeah. So I'm giving web one. Okay, yeah. So if I wanted to select a specific region or specific zone, I can give -R, I can say US. Okay, location, sorry, this is for location. Location, US. Class, standard or core, like that. I can provide. Okay. All these things are available in the Google Cloud document. Everything is available. If you go to GSUtil commands. So these days, guys, if I have interest, you can learn everything from Google. Okay. See here, you can see GSUtil commands. In the GSUtil commands, you can go to the MD, make bucket.
Yes.
In the make bucket, if you click, they're showing complete synopsis. -L is for location, -C is for class. This is the command samples also given. Standard class, location, yes, east one, bucket. If you don't give anything, by default, it will take the default storage. Okay. So now I can create a new bucket with the GSUtil. This web one. I think it should be perfect. See, it is created. If I want to check GSUtil but must be common guys. After that, LS list. Now you can see web one is created or not. Yes, it is created. So this is the way to work with real-time environment. Okay. Maybe మీరు ఏదో ఇన్స్టిట్యూట్కి వెళ్తే ఇక్కడ వరకు వెళ్ళరు. ఇక్కడ జస్ట్ బకెట్ ఎలా క్రియేట్ చేయాలి చేసి చేస్తారు. But that's not the correct way. So just I wanted to show the scripts also. So I wanted to take some sales data, okay, product data, sales data, and customer data. If I want to take the product data, developer has to build like this. These are the comments. All these comments are required to do. See guys, okay, create a bucket in GCS. This is the command. Okay, this command will be given to the platform team. They will write a Terraform script, Terraform script to YAML script will build చేసి this command will be executed through the command. Okay, but as a developer, we have to give this. You want to create a table, yes, you have to create a table. BQ, BigQuery, MK, make -T table, -V view, data set, like that. Sales domain, in that product is the table. This is the schema, guys. You have to give the schema like this. Then this will be pushed to GitHub. Okay. So I'm going a little bit into real-time manner. So non-working people try to understand. So there is a Git called repository. All scripts will push to the GitHub. From the GitHub, testers will take the data. Tester will take the scripts and test it. Tester will test. After that, platform team will perform in production. Okay. So that is the reason we have to go through with command prompt. Without command prompt, we can't do anything. Okay. So that's how we can create a bucket here. So if you click refresh, you can see bucket is created. Okay. If I want to copy the data, generally, I can open the bucket. The drag and drop also there here. Upload a file, upload a folder, like Google Drive. But this is not the correct way. Again, we have to go with commands. Copy the data. See, GSUtil, CP is the source to which bucket you want to copy. Okay, if I want to copy this dim product.csv file into this particular bucket, I can copy this. I can execute this command in the command prompt. CLS for clear. If I want to clear, I can use clear. Okay, this is the command. CP. This is the file, but the bucket name is different, right? What is the bucket I have given? CDE web. Web or web one. I have created both. Okay. Enter. Now you can see data is copied. These are the commands we have to perform every day because of every day we are getting data from source system. Who will do this copy every day? Right? If I load the data from front end like this, upload a file, go to the folder, but who will do every day? There will be thousands of tables, right? So that is the reason we will implement a command. This command will be executed every day, particular time. Okay, through scheduling concept. For scheduling concept, we are using Airflow. Okay, Airflow is the tool. So now I can check the data is stored or not. CDE web, quickly, you can see.
Either through Airflow or Python script or shell script you can write.
Sorry?
Python script or shell script to execute that command.
Yeah, we can do the same thing through Python script also. Okay, guys. So if I want to remove any bucket, I can use RM. Okay. So like that, after storage, I would like to storage is clear. Okay, just you can store any kind of data at any point of time. Then after that, data transformation and enrichment.
Satish.
Yeah.
Satish, one question. Satish, you told that after the codes have been saved in the GitHub, correct?
Yeah.
I mean, the tester will take the codes from there to test it, correct?
Yes.
Okay. Here the question is like, I mean, usually the developer will develop in the developing environment. Okay. And that code will be pushed on the testing environment where the tester will test it. Is that they will be working in the same environment or it will be a different environment?
Right.
No, you mentioned that it was
it's based on situation, project to project will change. It is not the concept of environment. Whether you are using daily or monthly. Just I wanted to explain more about storage. Okay. So you're asking how can tester will take the code?
Usually
that
they
is
will
different
not take
concept.
it. Yes, they will not take it, right? That's what.
Yeah, they will not take it. Yeah.
Okay.
So here almost 80% people are non-working people. Okay. I'm making in a simple way. I'm not going more depth. Already in the last 15-20 minutes, I'm talking too much technical, which will be difficult to understand other people, I know. Okay. But as part of the webinar, I have to talk about technical. Okay.
Sure. Yeah.
So next, data movement, data transformation. So here, once we load the data here, then we need to transform the data. Data is already there in the bucket. Data is coming here. See, dim product data is there. So just I wanted to show some data set, how exactly it is. So generally, we will get the data from the source streams like CSV format, text format like that. Okay. Customer data, I'm opening. This is the customer data will come like this: customer code, customer platform, channel, market, subzone, reason like that. Okay, and if I open sales domain data, you can see date to product code, customer code. Okay, year, division, segment. There are almost many columns. Data wise, I can see there are 10 lakhs records, 10 lakhs 40,000 records on this file. Okay, even this much data can be easily managed in BigQuery. Okay, so here in the BigQuery, there is a good thing. If you want to create a table, you have to create schema like this, right? Okay, customer code into 64, customer string, platform string like that. But there are 150 columns are there, then how can you do that? Understand? But there is a auto schema concept is there. Okay, BigQuery easily load the data. Okay, so just I'm opening BigQuery. Yes, if you have any understanding on databases and data warehouses, installation, configuration, setup, everything is required. That the BigQuery is like a serverless data warehouse case. Serverless. That means no need to think about anything. Just to click, open, and click on a query window. That's it. You can write anything here now. This much easy. It did not take even a half minute to open. I can click query. Here I can write that query. That is the advantage of it. If I click enter star, this query will take 12.93 KB of data. That is also giving immediately. Okay, sometimes we don't know. Suppose I'm taking about the sales file. Okay, details wise we can see how many records are 10 lakh records. Okay, if I want to query it by using star, you can see this, it is executing 223 MB of data. So based on this particular information, I can control my query because of the costing will be based on the size of data. Okay, the best thing is I can say 2 words about BigQuery, guys. BigQuery is a serverless. Serverless means as a developer, as a data engineer, you need not worry about the server's configuration settings. But behind, Google will take it. Serverless, highly scalable, distributed, okay, cloud-based, data fully managed, distributed, fully managed, cloud-based data warehouse tool, which can manage petabytes of data in minutes. That is the BigQuery. Okay, all these features are not available in any data warehouse. How much petabytes of data? It can result in minutes. Understand? And it's a column-based data warehouse. That means the cost will be changed based on the column also. If I select, it is executing approximately 223 MB, right? So I wanted to know, I don't want to execute all. I wanted to see the schema. I want date and product code, suppose. Now I'm removing star. I want to use date. See the help also coming, comma, product code. Now see from 230 MB to 21 MB. This kind of architecture is there. It will not touch 230 MB. It will not cost 230 MB of data. It will touch only 21 MB. So BigQuery is saying, when you need only 4 columns, why you need to select 100 columns? Understand? That kind of minute level, we can manage the costing. Completely cost effective.
Yep.
Understand? So that is the advantage of Google Cloud. Even if I give star 10 lakhs of records, when I enter it, execute it, it will execute the data within seconds. See guys. Got it? So that is the advantage of Google Cloud. I did not create any cluster. I did not install anything. I did not initiate anything. Just directly I went there and copied it. Table creation is also very easy. You can create the table in multiple ways. Here, you can create the empty table, or you can create the Google Cloud Storage, GCS, you can create upload from local machine. You can upload the data from Google Drive, Google Bigtable, or Amazon S3 and Azure Blob. Data set is in Azure. You can create a table here. Yeah, data will be captured from directly from blob to other. That means multi-cloud working. Understand? So we can create like this. So even if you click Google Cloud, I can select a table here itself.
Google, we are selecting Google Cloud Storage. What is the difference between bucket and Google Cloud Storage?
Storage is nothing but bucket which we created. Drive means your Gmail drive.
No, here, create a table from, table from storage.
Storage.
Here.
Okay. So I have selected this file. Okay. So file format is CSV. I can say if it's not CSV, something else I can select.
Yeah.
Okay. CSV. And partitioning concept also there. I don't want to talk now. It's a little bit different. So what is the table name? Okay. Sales webinar. Okay. And here, yeah, I can create schema based on this table, based on this data. There are multiple things are there, right? Which will be little difficult to create. But in that case, I can select simply, I can select auto detect. That's it.
Okay.
Automatically schema will be taken, automatically it will create. Okay. Here you can see anything needs to be skipped. One record. Why one record needs to be skipped? Because of here, first row is not real data. It's a column names. So it needs to be skipped from the data. So this way I can create the table. The same thing I have to do in the command prompt in real time, as I told you. Okay. Here, like this. See guys. Format CSV,
Yeah.
skip leading row 1, hyphen auto detect, that's it. Automatically, see, simple line. There are 100 columns are there, 100 columns. Automatically that it will be detected. Okay. You have to provide the data set name properly. You have to give the table name. Okay. Domain table name from this particular CSV file. Understand? So that data will be created without giving schemas, which is already created now here. This is the table, sales table. So, and BigQuery is providing a view for schema here. You can see how it is loaded, and you can see details also, how much data is there, how many records are there. Okay, everything can be viewed. And you can see preview of data. For preview, no cost. It shows 50 records without any costing. You can see how exactly data loaded is correct or not. If you wanted to see in other data warehouses, you have to enter the query. Then cost will be there. No cost. Okay. And once I execute a query here, okay, with 100 these things, I can explore this data directly with the visualization tool, guys. Here, Looker Studio is there. Just click here, automatically it will go to the Looker Studio. You can do the visualization. Everything in a single click and single window. No more Power BI. That's the reason 27,000 jobs are here. Yeah, everything is, if you know a little bit of visualization reporting tool, you can do everything here. You can select the data, you can paste everything, chart, all charts are available. Okay. And if you have a already migrated with any data warehouse like Teradata, like that, if you want to migrate here, you can translate settings also there is. Directly you can do. Your application already implemented in Azure Synapse. You want to switch to BigQuery, simple. You need not write new query. Take the Synapse query, give it, automatically it will convert to BigQuery. You have a Hive, Hadoop, yes, MySQL, Netezza, Oracle, Postgres, Pestro, Redshift, Snowflake, Spark SQL, everything is available. Vertica. Teradata I can select, I can save. Now here, this is the newly added feature, guys. Here, when I'm writing a new query, it will take two splits. One is for Teradata. As it is, you can take the query, place it, and the right side you can convert into the new one. Okay, these many things. Even you can save the result directly from here. Google Drive, local file, new delimited, JSON, CSV, Google Sheets, copy. You can store the file and you can analyze it with the reporting tool. Okay, even Colab Notebook. If you are a machine learning person, you can go with the Colab Notebook and write Python code to visualize the data. This is the advantage of BigQuery. BigQuery is doing very well in the industry. Okay. Understood, guys? Okay. So data transformations enrichment can be happen within the BigQuery. You can write any query within the BigQuery from stage to stage. You can do. Okay. Or else I can directly take the data flow here. Just I want to show data flow. I'll stop it here. I can use data flow or data flow. Data is the data flow streaming analytics. Here I can create a job from templates. You need not write much code, guys. Here templates already available. Almost 40 plus templates are there. You can use those templates. Just we need to enable the API. Okay, I'll finish another 10 minutes, then I'll take all the questions. So this is completely transformation. The BigQuery is the data warehouse. Not only BigQuery, you can use any data warehouse based on the cloud. Okay, so job name, some test CDE, Cloud Data Engineer. So now you can see, guys, how many templates are available here. These many templates are there. Suppose you are getting a data from GCS bucket. Okay, see, you can use GCS bucket to BigQuery, data stream to BigQuery, Kafka to BigQuery, MongoDB to BigQuery, PubSub to BigQuery. All are available. Pipeline as part of the pipeline. You are getting text file. You wanted to store in Google Cloud Storage and BigQuery. The pipeline is available. Okay, so data is coming in different format like Avro format. Yes. BigQuery to Elasticsearch, BigQuery to MongoDB, these third-party systems.
Yeah.
Even that is possible. Cassandra to Bigtable. Okay. There are, I think it's increased almost 50 plus are there. You can write your own custom template. These many things already available. You did not write all the code. 80% code is available. Once you click it, then you can write your customized code on top of this. Nowadays, APIs are coming well, right? API related templates are there. All are available. You can select any template and you can write your code and you can use it. Data will be coming from like this. Data is coming from GCS storage. Finally, you want to store into the BigQuery. But in between, you wanted to do some processing. Here you can use data. This is pipeline. In BigQuery, again, we have a 3 layers. Stage, history, views. Understand? From views, here, machine learning people will take the data. Okay? Reporting will take the data. And from to GCS, data is coming from landing zone. Right? To landing zone, data is coming from source DB. This is called pipeline. Understand? In this pipeline, as a data engineer, we are involving from here to here. Understand? With the help of these tools. This one, you can see. Okay, at least did you learn something, guys?
Very good.
Thank you.
Very good.
Online people, at least did you learn something? Did you know at least new things?
Yes, sir.
Yeah.
Hi,
Thank you,
Satish.
thank you, Sudha. Thank you.
Satish, Satish,
Yeah,
this
yeah.
is Subramaniam. So,
Yes, Subramanya, I'm coming to the questions in another 2 minutes. Just give me 2
okay,
minutes.
okay.
Okay. So if you are not able to understand, guys, so we have a just I want to talk about Qualicut for 2 minutes. Okay, we have 24th Friday. We have Azure JOIP data engineering program is there. Data engineering. Okay, 3rd March we have GCP JOIP job oriented intensive program is there. Okay, as part of this program, we are conducting 45 to 60 days program per day 8 hours. Okay, you cannot find this kind of training anywhere. Per day 8 hours. We will start learning from scratch from SQL. My students got the job before joining here. They don't know what is SQL abbreviation. They don't know even full form of SQL. Every batch there will be 10 plus people, but they are getting 10 lakhs package. So my training will be like that. We will make sure you will be capable of getting the data engineering job. Okay, so this is going to be happen. Just I wanted to do one webinar. So every month I am going to do webinars. Next time I will do more structural manner to cover the time and everything. Okay, and here if you have any doubts on my course, okay, just to go to Google. You can enter Quality Thought. You will see reviews, right? Reviews. Just you can see there are 66 Google Cloud are there. Okay, we have started just 1 year back. There are 66. You can data engineering 45. Guys, go here. You can read at least 5 to 10 reviews. Okay, if you like, then only you can turn. Or else not required. No need to. I'm not requesting anybody. If you're really interested, then you can turn. Okay. So people may think these reviews will write different people. You can name anybody here. I can show the person. I can show the offer letter from the person. Okay. Okay, guys. So because of my courses, people are coming through reference and reviews. Okay. So, and I have given a small interview in ITTV last time. I don't know whether it will come or not. YouTube, let me open YouTube. Just last 1 week, many people came to me. I have seen your video resume. Sorry, this. Let me ITTP data engineer. This one is. This is the one I have given here. This is my first interview I have given. We share the link. This is the link, right? Just I wanted to give you, just to go through that to know more about this course and other things. One in the meeting. Okay, guys, I hope you got this link. Even you can enter data engineering ITT. Okay, now, yeah, I will give the time for question and answers. Yeah. Surya Chandra, I think someone asking question, right? Yeah, Subramanian.
Sir, actually, currently I know about as a working with BigQuery and whatever you told, right? It's the Python GCS. But actually,
Okay.
I want to go to purely to the data engineering. So actually, I don't know about data flow. Python, I know little bit Python, Google Airflow, but I want as a PySpark and the data flow. So those much do the training. I think because
PySpark is 100% required because of Dataproc, Dataflow, Databricks, all are working with PySpark.
So yeah, you will teach right here in this.
Yes, 100%. Databricks, PySpark will be there.
Databricks also. And one more thing. So Azure Databricks and GCP Databricks. Is there any difference?
No. Databricks is completely different. Azure people are using Databricks. We'll call it as Azure Databricks. GCP people are using Databricks. GCP Databricks. That's it. Databricks will not change.
Okay, Databricks will not use. So here, if
Databricks
you
will
learn the
not change.
database,
You can open Databricks separately also. You need not go with anything here.
yeah, I saw here. Actually, Jekyll, I never saw and open. It was the Databricks. All
This is
the
the Databricks. You can directly restart. It's a free of cost per more year. Okay. So if you opening this Databricks in Azure, people will call Azure Databricks. Here you can do all the things here. Workspace.
Okay. So here the actually most of the people I saw that one Scala is the most required for the PySpark.
No more Scala. Maybe in 2017-18 it was good, but now everything is Python. People are turning to a Python only. We cannot learn multiple things, right? For Spark, Scala, for Airflow, Python, for data flows, Java.
That's the
Okay,
thing.
when Python is supporting to every technology, and Python is easy to learn.
Yeah,
Easy to learn. I know. I worked with Java 8 years. I know work with Scala. Okay, Python is very easy.
really earlier back 1 year back, I thought Python difficult, but we can.
Yeah.
And here the PySpark and Dataflow, Dataproc will teach, right, sir?
Yeah. So if it is GCP, we will work with Dataflow and Dataproc. If it is Azure, we will work with Azure Databricks.
Okay, I want only the GCP.
Yeah. Next, Surya.
Sorry.
Surya or Shivaram Krishna.
Hi Satish. Thanks for your time. First of all, Satish, I just have a couple of questions here. I mean, the couple of links you told you'll be sharing it. That's for the
ETL, ELTM.
yes,
Those
correct,
things, right?
correct.
Yeah.
Yes, those things have not shared. And the second thing is, I mean, Google Cloud Services, those things are, I mean, it's a free trial or how it is, it's a pay of cost.
Actually, once you register with your Gmail ID, they will give 24,000 credits, right? So
Okay.
it's paid only, but the money will be deducted from the 24,000, not from your credit card.
So come again. Sorry, I'm not getting you.
So you need not pay anything. Once you register, you will get the credits, free credits. Those free credits will be deducted when you use components.
Okay, because they are asking me to enter the credit card numbers and all.
Credit card is required. Yes, credit card is required. But don't worry, no auto payment will be there.
Oh, okay.
Because
fine.
I have done with many batches, guys. I have done with hundreds of people.
Okay. Yeah.
And
one more.
go
ahead, please. Sorry. Go ahead.
In my training, I will go and I will share the documents through Google Drive. So that till 13th batch I have run now. 14th batch is going to start. Okay. I will add every student into this particular Google Drive. I will show BigQuery, Airflow, Hadoop, Python, SQL, everything I will share like this.
Okay. And for BigQuery, do we have any separate tool like we'll be having a PLSQL developer or SQL server for the different SQL things, or how it will be?
Basic SQL is more than enough to work with BigQuery.
Oh, basic SQL is more enough. Okay, because I can able to see the queries for BigQuery contains like limit. Okay, if you're going for Oracle SQL doesn't contain limit. If you're going for SQL server, it contains limit 1, limit 100.
Yeah, 95% same, right? 5% variation is there. Even in BigQuery also, there will be 5% difference is there.
Okay, that's what I just want to, I mean, have a list.
I can say perfectly, I can say 80% SQL will be same for BigQuery, 20% will change.
Okay, fine, got it. Now I got it. And for Azure, we do have a separate, I mean, Azure Cloud Services, we do have a separate thing, or how it will be?
In Azure, we have a Synapse for data warehousing purpose. Our ADF is there, data factory.
Okay, good. And do you be sharing this video, I mean, recording session to us, or how?
Recording session will be there. Maybe after editing, if required, they will put it in the YouTube also.
Okay, fine. That should be good. Yeah, thanks, Satish. Thanks for your time. And
thank you.
For
Hello.
Thanks a lot. Welcome.
Satish?
If I'm not having a credit card, how can I open the GCP?
Satish, I have a query, Satish.
1 minute, Ram. If you don't have credit card, you can take any other credit card also. Don't worry. Credit card is not should not be your name. It can be anyone.
Okay.
Ravi.
One more thing. Sorry.
Okay.
Snowflake also here will be training. Any Snowflake also?
Sorry?
As part of the GCP, Snowflake also will teach here or?
No. As part of Azure, Snowflake will be there. As part of GCP, not required. We have BigQuery.
Okay.
That's it.
Okay.
Satish?
Yeah, Ravi.
Yes. Actually, cloud integration tool, right? That another Dell Boomi is also available. So is that actually completely separate or this is also included in data engineering side, or how we can treat that Dell Boomi?
Data
And what
engineering
will
is
be
not
future?
a specific content or component, right? Data engineering is a role. So you can use any technology. Many people are using still on-prem. People are using Netezza tools like that also still. So it's not really you separate or different. You can use that also.
Okay, that Dell Boomi.
Yeah. Other next question.
Yeah, Satish.
Yes, Surya.
Yeah, can you please elaborate this data section, how it could be class findings and practice, how it is divided?
Yeah, sorry, can you repeat your question?
Yeah, how it is divided for 8 hours for class and practice, how it is divided?
Yeah, actually, I will talk those things in demo. You can attend the demo, but morning 10 to 1.5 hour class will be there. Okay, then practice, and afternoon also again 2 or 2:30, again 1.5 hour class will be there. Then practice, and 1 to 2 hours communication class is there. Even communication also provided as part of this course. Okay, the people might not be good with the communication, right? We are providing this one. And every Saturday we will provide mock interviews for every student.
So this JOP is only for offline only, right?
Offline and online, both are available. If you are able to manage your work, you can join in online. But at least 15 days you have to come to class. When I'm going to talk about real-time projects, real-time execution, resume building, okay, at that point of time you have to come to class.
So, okay, understand. So after completing this course, in a real-time job, if you are getting any major issues, can you approach or?
Yeah, no need to approach with anyone. Just push your resume to Naukri. That's all. You will get a lot of calls. Many calls are there. Till in the recent time, testing there is no calls. DevOps no calls. Power BI no calls. But still, data engineering there are calls.
Okay, thank you, sir.
Okay, thank you. Yeah, any other question? Or else I will conclude. I will take the questions from classroom people.
Hello. Hi, Satish.
Yeah, or Sandeep.
Yeah, Satish, what is the salary package after we get selected in this?
Salary package, it's up to based on the person to person will vary. Okay, my people, my students got the package of 4.5 lakhs LPA to 54 lakhs LPA.
This is the jumping.
Huh?
This is the jumping.
54 lakhs LPA. Okay, this is the pressure. This is 20 years experienced person. Okay, so it's a current, based on your current experience, current package. But most of people got 12 lakhs is the best package. Average package I can say 12 lakhs.
Satish, for 10 years experience people, already they have 22 or 23. So if you know the data engineering very well, so to manage, because
for 10 years experience, 20 lakhs package, right?
so actually, if already if the existing person 20 lakhs
Yeah,
are there.
existing is 25 lakhs. Yeah, easily can cross 30 lakhs.
Okay.
After 54, the biggest packages are 43 lakhs, 40 lakhs. Okay, and in 30 lakhs, there are 4 options. Okay, 20 to 30. Okay, this is the biggest numbers. 10 to 20, there will be more than 100 to 150 in my world students. Okay, guys, thank you. Any other question from anyone?
Yes, Satish. Hello.
Yes, please.
Yeah, what are the prerequisites? Like what languages do we have knowledge to attend this course? Programming
Good question.
languages.
What are the prerequisites? If
Yeah.
if I say prerequisites, so only working people will come. Okay, anyways, they will get. I want prerequisites, so actually I will say 3 C's. Okay, first C, commitment required.
Okay.
Second C, basic communication required. Third C, common sense required. That's all. Okay. Then you can get the job after 2 months. 2 months commitment is required. Okay,
Okay.
learning commitment, practice commitment, coming to class. That is important. But I don't know ABCs, I don't know tenses. అంటే అది దానికి నేను ఏం చేయను. ఒక 1 month మీరు కమ్యూనికేషన్ నేర్చుకుని రావాలి. So here also communication is there, but how to behave with the team, how to send mails, how to talk to client. ఓకే, ఒక సాఫ్ట్వేర్ ఇంజనీర్ కావాల్సిన కమ్యూనికేషన్ నేర్పిస్తాం, అంతేగాని సింపుల్ టెన్స్ ప్రెసెంట్ టెన్స్ నేర్పించలేము కాబట్టి అవి కూడా కావాలి. సో దీస్ ఆర్ ద బేసిక్ థింగ్స్. మీకు SQL అంటే ఏంటో తెలియకపోయినా పర్వాలేదు. ఓకే, యూ కెన్ కమ్ అండ్ ప్రాక్టీస్. Okay, guys, thank you very much. I am feeling very happy. There are 100 people joined, 100+ people joined in the webinar. So thank you. So if anybody wants to join demos, especially Azure demo, GCP demo, you can contact my admin people. They can provide the link to you. You can join them. And even you can share the link to your friends or family members who doesn't have any experience, who are having a gap, BTech completed, civil engineering, mechanical engineering, 2017-18, 5 years gap ఉంది, లేకపోతే వేరే దాంట్లో వర్క్ చేశారు. This is the right time to enter into the software industry. You can share with them. If you are able to understand, then they can find.
Fee structure, admin will share
Fee
with us.
structure, they will tell you.
Okay.
Okay. Yeah, in demo. Webinar లో నా కోర్స్ గురించి మాట్లాడటం ఇష్టం లేదు. వెబినార్ షుడ్ బి వెబినార్. మీరు కొన్ని క్వశ్చన్లు అడిగారు కాబట్టి నేను చెప్పాను. బట్ డెమోలో ఐ విల్ ఎలాబరేట్ మై కోర్స్. ఓకే, వై GCP, వై Azure, వై నాట్ AWS, ప్యాకేజెస్ ఏంటి, ఎంతమంది జాయిన్ అయ్యారు, ఎంతమందికి జాబ్ వచ్చింది, ఏమేమి చేయాలి, అవన్నీ చెప్తాను.
Satish, when is the GCP demo? Any tentative date?
It's in
3rd March.
3rd March. Okay, I'll attend on 3rd March. Thank you.
Okay. PhD students 100% eligible. Guys, one thing, BCom 2000, BCom General 2002 pass out. Will he get the job? 20 years. No software experience. He got 14 lakhs package.
Yes.
BCom General. Okay.
Sir,
So ఇంతకు మించి ఇంకా ఉండదు నాకు తెలిసి. సో ఇంకా BSc నాకు 2015 ఓకే కాదా అని అడగక్కల క్వశ్చన్.
సార్ అది ఎక్స్పీరియన్స్డ్ ఫ్రెషర్ గా జాయిన్ అయ్యాడు సార్.
ఫ్రెషర్ గా ఎలా జాయిన్ అవుతాడండి 20 years అంటే?
అంటే కొన్ని స్టార్ట్అప్ కంపెనీస్
లేదు, స్టార్ట్అప్ కంపెనీస్ అయినా 2-3 సంవత్సరాలు అంటే ఎలా చేస్తాయి, మరి 20 years. సో టీచింగ్ ఫీల్డ్ లో 15 years ఎక్స్పీరియన్స్, 2 years ఏమో వేరే దాంట్లో, లాస్ట్ 3 years సాఫ్ట్వేర్ ఎక్స్పీరియన్స్ పెట్టి మేనేజ్మెంట్. Okay. Okay, guys, thank you guys. So you can watch my video if you want, and you can see the reviews from the Google, and you can attend my demo. After that, you can take the decision. No need to worry about it. Okay. Thank you very much for everyone.